This is a lesson on Chapter 7, Lesson 7, Solving Two-Step Inequalities. Let's take a second to review what the common inequality symbols are. This is the symbol for equals, used like 7 equals 7, greater than, like 8 is greater than 7, greater than or equal to, less than would be 6 is less than 7. Less than or equal to, we could put in, make this true, that 6 is less than 7. We're going to take a look at a few simple examples of inequalities, how to solve them and how to graph them. The good thing is that most of what you're going to work with in this lesson is very similar to equations. This is solved in a similar manner that you would use to solve n plus 2 is equal to 6. So we have to get the variable by itself. So we're going to be working to get n all by itself, all the variable here and all the numbers on the opposite side. So we have to say, how do we undo adding 2? And the answer is to subtract 2. So we put minus 2 and subtract 2 from 6. And the result is that n is greater than 4. Now, unlike equalities where if this was an equal symbol, then we would say that n equals 4, but there are many solutions to n is greater than 4. 5 is a solution, 100 is a solution, any number greater than 4. So anything that is greater than 4 will satisfy this condition. It can't be 4, so we don't want to include the 4, so we put a circle around 4. And then we just draw a ray that goes in the direction of greater than 4. And this is a graph of the solution. Any number greater than 4 works. If we wanted to solve an inequality that had to undo some multiplication, for example, double a number is greater than or equal to 6, we undo multiplying by dividing. And this would cancel out. And 6 divided by 2 gives us 3. So any number greater than or equal to 3 will satisfy this inequality. So we're going to say, here's our number line. We have to put any 2 points on there, but one of the end points is a 3. So we have to have a 3 for sure. And a very commonly used second point is a 0. In this inequality, n can equal 3, so we're going to put a dot, not as compared to a circle. A dot is compared to a circle at 3. This is another greater than, so we make it bold going in the greater than direction, and it's a ray, so we put an arrowhead on it. Something that I had said earlier that it's almost like solving equations. This is one that's going to be an exception to that. It's similar to, but something has to happen that's kind of weird, you might say. Let me start with a true statement that 8 is greater. Let me do a little bit better than that. 8 is greater than 7. True statement. What happens if I multiply both sides by -1? I'm going to go ahead and leave this and put a question mark over it. We get -8 is greater than -7, which is not true. -8 is less than -7. And on the number line, it would be further to the left. So it is a lesser value. So the rule is, if you multiply or divide by a negative number, you have to flip the inequality. So let me just take this out of there, because it's not true. The first thing I should do, as I'm getting ready to do this multiplication, is change this symbol to be less than. And then I can do the multiplication. -8 is less than -7, and that's true. That's going to apply to what has to happen when I undo multiplying by negative 2, which I'm going to do that by dividing by negative 2. When I write the results, I have to flip this inequality. So n will be less than, and 6 divided by negative 2 is negative 3. So when I graph it, I want to have a 0, and negative 3 is over to the left of 0. And it doesn't include negative 3, so I draw a circle at negative 3, and it's less than. So I bold in this part of it, put the arrowhead on it. And anything such as negative 10, negative 100, negative 5,000 will work, but positive 1 doesn't work. Negative 1 doesn't work. There's positive 1 would be in this area. Negative 1 would be in this area. They're not in the solution set, so I can't use them. So this slide is just showing us that if you multiply or divide by a negative number, you have to reverse the inequality symbol. Now we're going to go to the theme of this lesson, which is a two-step inequality, solving two-step inequalities. So we laid a little groundwork, and this is very similar to two-step equations. You can see right away that when I get to the 4a part, this is going to be dividing by positive 4a, so I'm not going to have to worry about flipping this inequality. It's going to stay less than or equal to. When I work backwards, if I start at 17 and I want to undo everything that happened over here, the first thing I have to undo is subtracting 3, and the opposite of that is to add 3. So I must do that to both sides, just with an equation. Sorry about that scribbly kind of a deal there. Make that look a little bit better. That should be, oops, plus 3. The result over here is, this is a 0 pair, so that would be a 0, leaving 4a is less than or equal to 20. Divide both sides by 4. And the result is a is less than or equal to 5. And when I graph it, I have to have a positive 5 on the graph. And again, 0 is very nice to put on there. Anything less than or equal to 5, so I put in a solid dot to indicate that 5 works, because 5 is less than or equal to 5. So 5 fits, and anything in this direction will work. It's number 13 from page 169. You can see it's got all kinds of stuff in it. It looks very intimidating. And I might actually, I'll work in this space down here. I might have to slide it up to finish it up. We'll see how I can go here. Just like equations, I have to simplify everything on both sides. So that's pretty easy over here. That's already done. There's a whole bunch of stuff that has to happen here. I've got parentheses, but I can't do g plus 5, so that's simplified. I can't do g minus 1. I have a distributed property, 2 different places. 7 is distributed to g and 5. And then 2 is distributed to g and to 1. This gets a little more complicated because it's subtraction here and subtraction here. So what do you think I would want you to do to make it obvious? There are several ways you can go about dealing with these subtractions, but I'm trying to be consistent in telling you there's one way that you can always be sure you're getting the right answer. And I hope you're thinking, make it add the opposite. So make this plus negative 2. I have to kind of put it way up there because the stylus it's not real delicate. And I make this plus negative 1. So when I go to simplify it using the distributive property, 7 gets multiplied by g, and then I'm going to add that to 7 times 5. So it's going to be 7g plus 7 times 5 gives me 35. Plus negative 2 times g, which results in negative 2g. And the only reason I'm putting parentheses in here is to separate the addition symbol from the negative sign. Then I have to do negative 2 times negative 1. It's going to be plus the product of negative 2 and negative 1. And that's kind of nice because that works out to be a positive 2. Is greater than or equal to 7. Now I have two types of terms. I've got the constants, the 35 and the 2, so I can put them together, and that'll result in 37. Then I have the 7g and the negative 2g. They're like each other because it's the same variable to the same power, g to the first power. So if I have seven positives and 2 negatives, the net would be, I have more positives. How many more do I have? 5. So it's going to be 5g plus, remember what 35 and 2 was? 37 is greater than or equal to positive 7. Okay, starting to look a little more manageable now. So to undo adding 37, I have to subtract 37. If you wanted to, as you anticipate what's going to happen over here with the positive 7, you could think, I would rather add negative 37 than subtract 37, because it's the same thing. If you add negative 37, you have a 0 pair. If you add negative 37 to positive 7, you get this subtraction problem. What's the difference between 37 and 7? That's 30. And you think about my rule for deciding whether it's positive or negative is which do I have more of, positives or negatives? And the answer is negatives. So here's my 0 pair. Not going to be there anymore. Equals, this is a negative 30. 5g equals negative 30. Should be getting to be old hat for you by now. How do you undo multiplying by 5? And the familiar division bar. Make that, close that in a little bit. That's 5. Divide by 5. Divide both sides by 5. That leaves you with g. Oops. I hope you saw that. Should be greater than or equal to, g is greater than or equal to 30 divided by 5 is 6, and we want to make that negative 6. So g is greater than or equal to negative 6. So I'm going to graph this on a number line. So I'm going to have a 0, and I'll go to the left of 0 for negative 6. The equals to part tells me dot. The greater than tells me move to the right. So that's how we solve and graph two-step inequalities.